You think the sun is eternal? Look out your window. That gentle yellow light is the only thing keeping your blood from freezing and the sky from falling. But what if an invisible hand hit the replace button, swapping our sun for another star? Every twinkling light up there is a deadly roll of the cosmic dice for any unlucky planet in its orbit. If you want to survive this experiment, you might want to subscribe before things go completely dark. Welcome to the Cosmic Laboratory. We are locking Earth in at exactly 93 million miles away and dragging the universe's most monstrous celestial bodies right into our solar system. We will go from sweet visual illusions to deaths where the laws of physics simply collapse. The simulation is active. Our first victim is ready.
The simulation drops Alpha Centauri b into the center. At first, you wouldn't even scream. Human eyes adapt to the dark perfectly. Brightness simply drops by half, and the sky turns a warm, eternal orange. It feels like a peaceful late afternoon. But this romance is just the opening act for a very quiet death. Before the cold even hits, global vegetation goes on a permanent strike. Without that missing 50% of light, photosynthesis shuts down. The green of our forests fades into the shadows. Then, the atmosphere crashes. Global temperatures plummet to -70 degrees Fahrenheit. The oceans freeze over. As white snow blankets the continents, it acts like a giant mirror, reflecting what little light we have left back into space. More reflection means more cold. Earth becomes a dead snowball. But it gets worse. This star is only 90% of our sun's mass. Its weaker gravitational grip means Earth's momentum flings us out into a wider, colder orbit. Your only hope is a deep bunker powered by nuclear heat. To save the surface, we'd have to play God and shove Earth closer to this star's habitable zone. We thaw the ice, sure, but time itself shatters. A year is violently compressed to just 225 days. Say goodbye to the seasons you know.
Think that shrinking year was bad? The simulation now swaps in Kepler-16, a binary star system. At first, you're in a cinematic dream. Imagine stepping outside to a double sunrise straight out of Star Wars. A small orange sphere and a dim red companion climb the horizon together. Look down, and you cast two distinct shadows that slide and crisscross all day. It's breathtaking. But beauty is useless. Combined, these stars output barely 15% of our sun's energy. If we stay parked, Earth becomes a solid block of ice. So we drag our planet inward, dropping it right where Mercury used to be. You survive the freeze, but time goes insane. Your year now lasts just 94 days. Because these stars orbit each other every 41 days, the light hitting Earth pulses. You get bizarre mini-seasons stacked on top of regular ones, and every few weeks, a deep 6-hour eclipse plunges your daytime into darkness. Yet light isn't the real killer, it's gravity. Welcome to the infamous three-body problem. Orbiting two constantly moving massive objects creates pure gravitational chaos. Within a few thousand years, Earth faces 3 guaranteed death sentences: torn apart by tidal forces, swallowed by a sun, or violently ejected into the pitch-black void of interstellar space. You got your double sunset, but it cost you an entire planet.
So you lost a planet. Let's reload the simulation and try our closest stellar neighbor, Proxima Centauri. It's a red dwarf, outputting a pathetic 0.17% of our sun's energy. If you look up at exactly high noon, the sky isn't blue, it's pitch black, filled with thousands of stars and a tiny glowing red dot. At our current 93 million mile distance, Earth doesn't just freeze, the atmosphere itself collapses. Carbon dioxide falls as dry ice snow. Nitrogen and oxygen condense into liquid rain, burying the world under meters of alien frost. To survive, we drag Earth violently inward until your entire year lasts just 8 days. But at this point-blank range, Proxima's gravity locks us in place. Welcome to tidal locking. Earth stops spinning relative to the star, One hemisphere is a permanent boiling frying pan, the other an eternal pitch-black ice age. From space, we look like a giant, gruesome eyeball. Your only refuge is the Terminator line, a narrow strip of eternal twilight. But forget about green forests. To survive under this weak red light, plants evolved to absorb the entire infrared spectrum. The wild forests here are pitch black or a deep, haunting purple. Don't get too comfortable in your purple paradise. Proxima is a flare star. It is incredibly violent. If you ever see giant auroras suddenly ignite the daytime sky, run. It means the star just flared, glowing 60 times brighter in minutes. You are about to be roasted by X-rays and UV radiation. Over millennia, this relentless radioactive bombardment simply violently peels away our fragile atmosphere, blasting our air into the endless void. So far, every star has just been a disk in the sky, but Betelgeuse breaks that rule. Its diameter is up to 1,000 times larger than our sun. If we dropped this red supergiant into the center of our solar system, its surface stretches all the way past the orbit of Mars. You wouldn't look up and see a star. You would look up and see the entire sky replaced by a crushing, boiling wall of orange plasma. Earth doesn't orbit Betelgeuse. Earth is inside it. We vaporize in less than a millisecond. And in that fraction of a second before we burn, you would notice its surface isn't smooth. It is boiling. It is covered in massive convection cells, bubbles of rolling plasma. Just one of those bubbles is the size of our entire original sun. To survive this monster, we have to drag Earth way out into the dark, pulling it completely past the orbit of Jupiter. Out here, time stretches. A single Earth year now drags on for 12 long years. One punishing season bleeds into 3 solid years. But the cold out here isn't your biggest problem. Betelgeuse is dying. It is out of hydrogen and desperately burning a helium core. Sometime in the next 100,000 years, or perhaps tomorrow afternoon, it will detonate into a supernova glowing 10 billion times brighter than our sun. When it blows, a ghostly wave of neutrinos will wash through Earth in dead silence. Hours later, the blinding flash arrives, turning the midnight sky at Jupiter's orbit brighter than high noon, stripping our ozone and melting the planet's surface all over again. There is absolutely nowhere to hide.
Let's scale things down. What if the next star in our simulation isn't massive at all? What if you walk outside and see absolutely nothing? Just a pitch-black sky, no sunrise. But the first sign of doom doesn't come from above, it comes from your pocket. Your phone speaker crackles with static. Before Vela Pulsar even shows its face, its electromagnetic pulse hits Earth, frying every microchip and collapsing the global power grid in seconds. Humanity is instantly blind and deaf. Welcome to the Vela Pulsar. Imagine a dead stellar corpse, heavier than our sun, but crushed into a sphere the size of a city, barely 12 miles across. It spins like a buzzsaw, rotating 11 times every second. From its poles, magnetic fields blast twin beams of ionizing radiation sweeping across the cosmos like a lighthouse of death. Suddenly, your dark horizon erupts with pale green auroras, flashing perfectly in time with the star's heartbeat. Beautiful, but fatal. That isn't light, it's pure radiation. These beams immediately strip away our ozone layer and shred the DNA of anything unlucky enough to be facing them. With the other stars, we tried finding a habitable zone. With a pulsar, that concept is a joke. It emits almost no visible light or warming heat. Stay far away and you freeze solid in the dark. Move closer and you are microwaved on a cellular level. You get to experience a magnificent hell, freezing in the absolute dark while your cells are simultaneously cremated by radiation. Up until now, we have been playing with stars, different sizes, different ways to die. But our final imposter isn't a star at all. It is the monster lurking at the center of our Milky Way, the supermassive black hole, Sagittarius A star. Imagine 4 million suns crushed into a space smaller than the orbit of Mercury. You step outside, and there is no dawn, no direct light. You just see a massive, terrifying hole punched right through the sky, a perfect circle of absolute nothingness. But that void isn't entirely dark. It is surrounded by an accretion disk, a death halo of superheated matter spinning at nearly the speed of light. The friction generates temperatures in the millions of degrees. The gravity here is so incomprehensibly immense that it bends the light of distant stars, stretching them into brilliant, sweeping arcs around the edge of the hole. It is gravitational lensing, and it is the most beautiful and terrifying thing you will ever see. Don't stare too long. That glowing halo is blasting out dense X-rays and gamma rays, roasting our planet. But let's say Earth's orbit slips inward. You won't crash into a solid surface. Instead, the gravity acting on your feet becomes millions of times stronger than the gravity on your head. Your body and the entire planet gets violently stretched out into a thin river of subatomic noodles. Physicists actually call this spaghettification. Finally, that river of matter spirals past the event horizon, the point of no return. To an outside observer, Earth would seem to freeze, fade to red, and stay there forever. But for us, it is a silent freefall into a bottomless pit. No explosion, just the quiet end of space and time.
The next time you look up at the night sky, do not just see romantic twinkling lights. Every single star out there is a different version of this deadly experiment. It is a ruthless roll of the cosmic dice for any planet caught in their gravitational grip. After surviving ice ages, radiation tsunamis, and black holes, you finally realize how ridiculously lucky we are. We hit the cosmic jackpot. Our sun, a G-type main sequence yellow dwarf, has a perfectly absurd balance of temperature, luminosity, and stability. So tomorrow morning, when that warm sunlight hits your face, do not take it for granted. It is humanity's one winning lottery ticket in a universe full of serial killers. If you survived this cosmic simulation and want to explore more mind-bending space experiments, hit the like button, subscribe, and ring the bell. Do it before the simulation resets.